Welcome to another lesson with you-know-who, Mrs. Harding. Today's lesson is going to be about polygons. You've been doing a lot of work with quadrilaterals, and now we're going to start working with other polygons as well. So remember that all polygons can be named simply using the number of sides and attaching a gon to it. So for example, a triangle that has 3 sides can also be called a three-gon. And a quadrilateral, which has 4 sides, can also be called a four-gon. What would a polygon with n sides be called? An n-gon. So basically, you just take the number of sides and add gon to it. Now, we have some special named ways to name certain polygons. So remember that this is a triangle, and hopefully we know this is a quadrilateral since we've been doing that for a couple days. Okay. The next one, hopefully we'd also know because of government, pentagon. 6 is hexagon. 7 sides is heptagon. Now, a lot of times with these two, people spell it wrong and go, oh, I meant the other one. Okay, I'm going to go with the spelling on what it looks like. So I would just make sure you know how to spell hexagon and heptagon. 8, hopefully you know because of a stop sign, octagon, especially since a lot of us are currently in driver's ed and turning 16 soon or already turned 16. 9 is a nonagon. And 10 is a decagon. Okay. So you should really know these first 10. Okay, these are just the very basic polygons. After that, it becomes a little bit more crazy. So 11 is an undecagon. 12 is a dodecagon. I hope you're having fun with these names now. 13 is a tridecagon, or we could just say a 13gon, right? That would be a lot simpler. 14 is a tetradecagon. 15 is a pentadecagon. 16 is a hexadecagon. Or again, we could just say 16gon and be done with the problem. 17 is a heptadecagon. 18 is an octadecagon. Hopefully you're starting to see a little bit of a pattern. 19 is an ennedecagon. And 20 is an isogon. Again, you could just say 20gon. So which ones should you really know? You should really know these 10 by their special names and not just a 3gon or a 5gon. After that, you guys can just use the number of sides gon. Okay? All right, next notes. So just remember that we have convex and concave polygons. Convex is that you draw a line straight through a convex polygon and crosses at most 2 sides. So notice that this line that's drawn here meets the polygon at 2 sides. Over here, 2 sides. Every interior angle is less than 180 degrees. Okay. Concave is when you draw at least one straight line through a concave polygon that crosses more than 2 sides. So notice that we cross 1, 2, 3, and 4. If I did it here, I'd cross 1, 2, and 3. At least one interior angle is more than 180 degrees, so that's the big difference between a concave and a convex. At least one interior angle is more than 180. Here, for convex, every interior angle is less than 180. Okay, and again, how do you know the difference between the concave caves in? Okay, All right, some vocabulary words. So these are all sides. A vertex is where those two sides meet. Diagonal is from one vertex to the next one that isn't the same side. So like I couldn't go from here to here. That would not be a diagonal. Okay, but there is another diagonal here and here. Okay, and then we even have more. I mean, we have diagonals here, here, and here. So you can draw multiple diagonals with shapes. Interior angle is on the inside. Exterior angle is formed outside the polygon by extending a side of the polygon. So notice how this is extended. So exterior angle. I could do it here. Exterior angle. Here. Exterior angle. It doesn't matter. It just has to extend outside the polygon. Okay, so these are three formulas that you need to have memorized. The first one is the sum of all the interior angles of an inside polygon is n minus 2 times 180. Okay. So for example, if I gave you a polygon, let's say with 6 sides, and I said find the sum of all the interior angles of that polygon, then you would just substitute 6 in and then times that by 180. Which gives us 720 degrees. Okay. The sum of all exterior angles of a polygon with n sides, it doesn't matter if it's a triangle, doesn't matter if it is a dodecagon, it will always be 360 degrees. So if you're asked a problem to find the measure of an exterior angle of, let's say, a 6-sided figure, so n equals 6, all you would do is you would take 360 divided by 6, and that gives you 60 degrees. So no matter what, it doesn't matter how many sides, okay, the sum of all exterior angles will always be 360 degrees. And then finally, the number of diagonals, this formula is a little bit more involved, is n times n minus 3 over 2. So hypothetically, let's say n is 3, then that's a triangle, right? So if I did the math there, we would get 0, which makes sense because if you have a triangle, you can't form a diagonal, right? Without being along a side. All right, let's do a quadrilateral. So n equals 4. So 4 times 4 minus 3 divided by 2 gives me 2, which would make sense because we've talked about how a quadrilateral will only ever have 2 diagonals. Okay? So the most important thing is to get these three formulas memorized. You're going to use them arithmetically quite a bit. So sum of interior angles is n minus 2 times 180. Exterior, no matter what, is 360. And then number of diagonals is n times n minus 3 over 2. Thanks for tuning in.